Today we have an expert working in a field. The topic of today's talk is using satellite thermal data to benefit agriculture, and I believe this is worldwide. We are very lucky to have with us Tobias Menne from Germany. He grew up on a farm. Don't know whether he continued to love farming, but he's involved in farming. He studied business and psychology and certainly has deep knowledge about this subject. So let's listen to him. Over to you.
It's a pleasure being part of your podcast here and your webcast. Personally, I've been spending all my life in agriculture, and I've been running a large farm in Ukraine for quite some time. And I came across so many different challenges a grower and me as a grower is facing today. And this is, I mean, especially really due to understand how do I really efficiently bring a crop through the season. I mean, it's not about, bringing the crop through the season. Everyone can do that. But, as a grower, you also need to really make a profit on this. You need to be efficient in doing this. You have incredibly few people really working on a farm and really understanding what's going on a field. And out of that conviction, I understood that we need more data, that we need better data to really understand what's going on a field, to not see this individual field anymore as one data point, but much more as and almost look at every plant, if you like, to really understand what's a potential and how can we efficiently really bring this crop across a finishing line, meaning to harvest at the end of the season.
Yeah, thank you so much, Toby, for that insight. As what I know a little bit is that most of the revolutions that have taken place in agriculture were either to find inputs that are suitable for making the crops grow better, or hybridizing the plant in some way so that it is resistant to whatever you want it to be resistant to and responsive to whatever it is that you want it to be responsive to. But all of that stopped after you did the planting.
Correct.
You did the planting and then you prayed. You say, okay, maybe I'll have the inputs, maybe I won't have the inputs in time. And then what happens after that? That was really based on old-fashioned intuition and experience and knowledge. And we need to bring it into the modern age, the satellite age, the data age. And that, I think, is a big revolution in agriculture because we don't have it. The traditional, Nobel Borlaug, from India's perspective, I'm speaking, he won the Nobel Prize, created the so-called Green Revolution, and turned India from being a food short country into a food exporter, right? That's great. And, I've lived through that change and I've seen it myself, how it was before the Green Revolution, very tough, and now how it is when it's different. But the whole revolution stops once you've done the planting. And I think it's very important to hear from you how you take care of it, how you understand it after the planting is done.
And once the planting is done, I mean, in the past, growers had even more resources probably than they have today. I mean, probably the farm in the past was smaller. There were more people working on the farm. Probably also the education level was at least at par. Probably very often that farm was run already by the family for sometimes generations. So a lot of wealth of experience was already accumulated. Also, in the past, growers had more means really and probably also better means to really ensure that the crop was coming through the season. They had more choice in terms of seeds, more choice in terms of crop protection. So the technology set to solve was very broad. And today, really for the best of all reasons, to protect us as humans and to protect us as an environment, in so many countries, we took the right decision really to restrict this. But that translates really into additional challenges with growers. And of course, at the same time, as innovation is also, for example, in the seed space, accelerating, as environmental change is accelerating, this what you described as the grower is seeding and then probably starts spraying, I believe has never been so true as it is today.
Okay, so let's see what you can do about it, or what you are doing about it.
So what I believe, many people and many companies, organizations, and professions really need to contribute here to the solution.
Okay.
I believe what we need is an agronomic decision-making system, which really integrates different data sources from genetics to weather information and climate information, to soil information, to the availability of nutrients, understanding the presence of soil-borne or airborne diseases, of weed pressure, of the machinery available, of the commodity prices, of the prices of machinery, to really help to support a grower to take the right decision for the farm level, for the field level, and then also for an individual plant level.
Oh,
And
wow.
I believe quite some of these, there are quite companies out there with that ambition of automating, improving, and automating agronomic decision making in a robustness that it's at least at par with a professional human agronomist. But also, I believe what was so far very often the limiting factor is that good quality data was not available. So the models have been developed by many, largely by academia over the last 20, sometimes 30 years, and they are really at a fantastic level of profession. Yet the quality, the data, the granularity and quality very often was not there to run the models.
Yeah, I get it. Right. Let's continue.
So here I'm personally working for Constellr. We're a company with own space assets, so we run an own fleet of satellites. Because from years ago when we started, we understood that we have overall this scarcity of high quality data, which is exact, which is repeatable, which comes at an attractive cost point. And therefore, so today, what we are contributing to this overall challenge we have as mankind is a data set which is coming from our own satellites, which is exactly measuring especially the temperature we have here on every almost square meter on the planet, to understand what's going on. What is the land surface temperature, but also what's the canopy temperature. And out of this, you can derive very, very simply and straightforward, how much water can the soil hold over a longer period of time? What is the stress of the crop? What type of stress that crop has? All as input factors into the described models to automate agriculture to the benefit of the grower, to the benefit of the environment, and to the benefit of all of us on the planet.
Yeah, I think that water point is critical because, the great innovation is drip irrigation. But drip irrigation is a kind of a non-responsive, automated, mechanical system. You just program it and it drips according to a schedule. But what you're saying is that if I have the actual data, right, about the situation on the ground, then I can water according to that, not according to a program.
Very much so. And let me maybe zero in on this. Very often growers I know also use soil sensors. So essentially just putting a soil sensor into the ground to measure the availability of humidity, right?
Yes.
And that is awesome because these sensors offer a very high temporal resolution of what's going on.
Yeah.
But what they very often fail is to understand what's really going on within a larger area. And they fail to understand what is going on in more deeper levels of the soil. And that's exactly where the plants really take their water from, right?
Yes.
If you look at many crops, they would take the water from up to 2 or 3 meters, and you have a certain capillary pressure within the soil pushing the water higher. So we believe it is, in addition to the soil sensors, crucial to monitor the crops to understand what kind of stress they have, because they signal to us even before any damage is done. The crop signals to us by changing the evapotranspiration through its leaves,
Yes.
and then the temperature is changing of the crop. So
Yes.
we then immediately get an idea, hey, something that needs to be done.
Wow, that is really responsive. It's actually responsive to the situation as it is occurring, right?
Yes,
And
exactly.
I think I've recently been involved in some activities which we can discuss later, but not in this recording, where the key is to realize what's happening to the roots. And the roots are deep.
Exactly.
For vegetables and all, they are not deep, but for many of the crops they go down, and especially if you have orchards, etc., then the crops are deep, and the roots are deep, and you really need to know what's happening at the root level rather than at the ground level, right? So
Exactly.
I think that is a very, very useful not additional, it is the key information, what's happening at the root level. And what you are saying is that what's happening there is reflected at the leaf level.
Exactly.
Right?
Exactly, because that is immediately translating. Almost the leaf level is emitting the signal
Yeah.
of how well the root system and the water availability there is doing.
Right. Okay. Wonderful. I love it. Let's continue.
Of course, so what a field is not homogeneous, right? And
No.
and we have a very high level of heterogeneity. Um, different soil compositions, sometimes more clay, more sandy, so more different soil types. The overall underground structure and its ability to allow water really to emerge is very different. Then, of course, you have terrain and slopes, and you have then slopes which are more geared towards the sun and slightly more shadowy slopes. So all of this really contributing to variability in the field. And here, as Constellr, we provide a superior data set in a grid of 10 by 10 meters to really measure this in a very high accuracy. And what is really crucial here, I'm so convinced that when we speak about agriculture, we need to look at time series.
Okay.
So it's not good enough really to look at one crop during one day to say it's fine or it's not fine. It's all about the change we observe day over day, and especially in a rhythm probably of 3 to 4 days, because under good conditions, 4 days is usually the time when a crop reaches the next growth stage.
Yeah.
So it's building a next pair of leaves, or it's sprouting, or yeah, wherever it is, or emerging at the very beginning of its growth stage. So really, by observing these growth stages and seeing how the crop is doing, we can help systems and growers to really understand, is a crop okay, or what's the level of stress, because only then the grower can really take countermeasures and take his crop really efficiently throughout the growing season.
Okay, wonderful. It's really very, very, what should I say, responsive to the plant's actual needs. rather than a formula.
Yeah, exactly. And you have to imagine that we have very often crops which are grown on fields which are so large that humans are struggling really to keep a good overview.
Yeah.
I, for example, recently was speaking with a customer of ours, a large citrus grower in South America, in Brazil. So he was so far in the past flying drones
Yeah.
to really keep an eye on over 100,000 hectares of citrus. And if you then really and at first glance, I was wondering, well, if you're already running a drone, what is truly still the need and the requirement of the grower, right? But then, the grower shared really very practical insights. When you use drone data, you have actually essentially not the same timestamp on your picture. You're flying a drone sometimes for 2 or 3 hours over one field.
Yeah.
Really gather data. So that means that, the sun changed, the temperature,
Yeah.
the ambient temperature changed.
Mm.
So it's incredibly difficult really to understand, well, are parts of my field doing different from what I expect them to do? Or is the difference I observe just a function of the different time collection of the time of the data?
Yeah. Okay. I understand. And if you have a
Mm,
large thing, heterogeneity is built in. Even the soil composition may be different, and
exactly.
the sun's
Yeah.
rays come at a different angle at different times of the day, and all
Yeah.
of that matters.
Yes.
If you are going to get down to the nitty-gritty of talking to the plant, really, then
Exactly.
you need to talk at the same time across the field to get a snapshot of what's happening. What you're saying is the drones are too slow. They cannot be simultaneous.
For large areas, when
Yeah.
they are when simply the timestamp also has a high relevance, and
Yeah.
I'm very much convinced that we need to look at change detection, right, in agriculture, and which really means you need to have that one picture and that one view on a field,
Yeah.
and but you also need to have a technology to really compare the picture today with the picture of yesterday and the picture of last year.
Right.
And I want to draw your attention here really to a new set of satellites and new set of technologies really coming, which really enable this, probably really for the first time.
Okay.
Because the sensors on the constellation are exactly calibrated to each other, yet also calibrated to existing public missions, so that you can really use public data and private data efficiently together. And also by the very differentiator of Constellr's technology, and that is, we found a way to essentially stabilize the sensor, the thermal sensor in orbit, so that the temperature reading we measure is correct, and has
Okay.
and we measure this correctness with a sensitivity of 100 millikelvin. So we sense the slightest difference in canopy, in temperature, or in land surface temperature, and that is something what is truly unique, and is also tremendously setting us apart from any other technology on the market.
Okay.
And this really then also helps to see changing patterns within the field when you compare yesterday versus today versus last year.
Okay. Wonderful. I mean, yes, we need that new technology, and not just in the seeds, but as I said, once the seeds are planted, we need the new technology for that time period. And perhaps
Yes.
as important as what's the input that you are providing, like fertilizer, but the water is critical, and you have that, and you have the variation as shown by very, very nano data. So it's really good. I'm happy.
Mm.
So let's continue.
The Constellr data is used today by customers for various applications in agriculture. A lot about stress identification, so biotic, abiotic stress, but also a lot around water and measuring water availability, and especially how stressed, how water stressed a certain crop is. Also, our data is very suitable to determine soil or biomass of crops, for example, of forests.
Yeah.
Yet it's I don't know. So, what if you want to talk about this now?
Sure.
The Constellr data is very much geared towards agriculture and environmental monitoring. Yet we see also that a lot of our customers use it to determine how well buildings are isolated. So in infrastructure monitoring. To determine the temperature of roads, for example, a supercritical component for autonomous driving. Understand if the road is frozen or not, or what's the overall situation of the road cover.
Okay.
And of course, also in the security area. So while our technology is very much geared towards agriculture, a lot of applications in infrastructure, in security space beyond this.
Yeah, for example, if the railway tracks get too hot, then you are in trouble, or the train cannot run. The safety is also slightly compromised because they're metallic tracks and they do expand and they do change. So I suspect that they would be able to find some use, because tracks do matter a lot in trains. Ultimately is the road for the trains, and what's the status of the track, that I don't know how they collect the data. They must have some way, but obviously you could use that to measure the temperature over there, and that could be this real time. Let's call it real time. It's real time data that you can provide. Yeah, good.
Yeah. For example, I mean, also we have customers in India who use our data to monitor electric grids, to understand if there is any kind of anomaly or fraud in the system, which you would more easily detect using a totally it's of course it's not uncorrelated, but it's our data comes simply from a very different system, and is not linked in any way then to the electric grid of the company, and so a lot of applications also beyond agriculture.
Okay, wonderful. Okay, anything else you want to add? I can just say that, look, just the agriculture part is fascinating, because we do need to use not less water or more water. We just need to use water efficiently so that
Exactly.
we get the maximum output. It's not a question of reducing. It's a question of, if we have to grow some stuff, how do we grow it with the right amount of water?
Yes, exactly.
That's exactly, I think, a very big challenge in many countries, and especially the demand for water intensive crops is pretty high. And when we say water intensive, it's because we don't know how to water them. We water them maybe too much, and maybe we could reduce that water use, make it more efficient. So I'm really personally and professionally, I'm an economist, but I'm interested in these things. So I'm happy. But this is not my talk. Please go ahead and add anything else you want to add.
So what I very much like your topic of how we organize water in a society.
Yeah.
And here I observed that, because out of missing data in so many countries, we have given water rights to growers based on a daily schedule, based on a weekly schedule, that certain farms would get data on a Wednesday afternoon between 4 p.m. and midnight. And what is a farmer doing in this situation? Of course, using all the data which is exactly coming through the pipe system in that time window, right?
Yeah.
So I believe using data to really rethink how we organize water markets, I believe that would be probably one of the biggest values we as Constellr could contribute also to reaching the Paris goals.
Okay. All right. I think it's a wonderful talk. Somehow I think I understand it, though I'm not an expert in this field at all. You've explained it so clearly that even others can understand it.
Perfect.
And what's the future for your company? That's what I would want to know.
So what we are launching more and more satellites to really increase the grid of our reading. So we will have a reading of every place on the planet at every day very, very soon. And we also really want to go beyond the 10 meter to a 5 meter, maybe to a 2 meter spatial resolution to address even more applications, especially also in the infrastructure monitoring, better than we are doing today.
Okay, great. All right. I think you have said all that you wanted to say, but in case you have something you want to add, please do so now.
I believe I said everything I wanted to
convey.
convey.
Great. Then let's end it here. Maybe we have you back in a year to give us some examples and show us exactly what you have been able to achieve. This is a general talk, but we can have a more detailed talk with examples and so on, and perhaps a more detailed explanation of how you do things, because it's a very important topic. So let's end it here for the moment. And let me just say I'll be back with another expert or another young person soon. But till then, bye, everybody. Bye.